Okay, so today we're going to talk about something that sounds a little bit like magic. Imagine taking pure random static, digital noise, and turning it into synthetic heartbeats that can help train doctors. Or using that exact same idea to build an invisible shield that protects AI from cyber attacks. It's all based on one core concept, and it's got some huge applications. Let's dive in.
I mean, seriously, how is that even possible? You look at a screen full of static, right? Just total digital chaos. How on earth do you turn that into a beautiful, photorealistic image? Or something even more complex, like medical data? Well, the answer is this incredible technique that has no exaggeration totally changed the game for generative AI.
And here it is, the star of our show, the diffusion model. Now, the basic idea is actually kind of simple, which is what's so cool about it. You start by teaching an AI to do something that sounds destructive. You teach it to take a perfectly good piece of data and just add noise, bit by bit, until it's nothing but static. Then comes the hard part. You say, okay, now learn how to undo all of that. Learn how to reverse the process perfectly. The best way to think about it is like a sculptor, but in reverse. The first part, the forward process, is like watching a beautiful statue just crumble away into a plain block of marble. But the second part, the reverse process, that's where the magic is. You give the AI that block of marble, that pure noise, and it's learned how to chisel away, piece by piece, to reveal a masterpiece. And this ability, this power to create something amazing from pure chaos, has some mind-blowing applications in the real world.
All right, so let's get into our first example. And this one is a big one. We're talking about medicine. This is where we see that this whole idea of reversing noise isn't just for making cool pictures. We're talking about generating data that could quite literally help save lives.
One of the biggest hurdles for AI in healthcare is just getting enough data. Think about it. If you want to train an AI to spot heart disease, you need tons and tons of heart scans, what they call ECGs. But that data is super sensitive, right? It's protected by all sorts of privacy laws, and it's just plain hard to get, especially if you're looking for examples of rare conditions. So this is where diffusion models come in with a really clever solution. What if you could just make more data? And that's exactly what researchers did. They took a diffusion model and fed it almost 22,000 real ECGs. The model just soaked it all up. It learned the super complex patterns of a human heartbeat for 71 different diseases. It learned what's normal, what's not, and everything in between. And the result? It's pretty amazing. The model can now just generate brand new, totally synthetic ECGs out of thin air for patients that don't even exist. And here's the kicker. When they show this fake data to actual cardiologists, the doctors say it looks completely real. This is a game changer, because now you can train better AI diagnostic tools without ever touching a real person's private data.
Okay, so creating new data is one thing, and it's incredible. But what's really wild is that this same idea, this denoising process, can be flipped on its head. You can use it not to create, but to protect. And that brings us to our second application, AI cybersecurity. Because for all their power, AI models can be, well, surprisingly easy to fool. Take a look at this. This is a classic example of what they call an adversarial attack. To you and me, that's a pig, no question about it. But an attacker can add this layer of digital noise to the image. It's totally invisible to the human eye, but it's enough to make the AI go completely haywire and see an airliner. Now, just think about what that means for something like a self-driving car. Yeah, it's a huge problem. So, how in the world do you defend against an attack you can't even see? Well, the solution has a pretty cool name, adversarial purification. The basic idea is you build a kind of digital shield that stands in front of your main AI, and its only job is to clean up any data that comes its way, stripping off that malicious noise before it ever gets a chance to cause trouble.
And this is exactly what a model called DiffPure does using, you guessed it, a diffusion model. So here's how it works. A potentially hacked image comes in. First, the DiffPure shield adds its own random noise all over it. This basically messes up the attacker's careful pattern. Then it does what it does best. It runs the reverse process, denoising the image. And since it's trained to remove all the noise, it takes away its own random noise and the attacker's malicious noise right along with it. It's basically like giving the image a digital scrub down.
And does it work? Oh yeah, this chart is showing what's called robust accuracy, which is just a fancy way of saying how well an AI holds up when it's under attack. You can see other defense methods really struggle, but DiffPure, it stays incredibly accurate. We're not talking about a small bump here.
This is a massive step forward for making AI safer and more reliable.
So let's just recap for a second. We've got this one single idea, learning how to reverse noise. And from that, we get AI that can create vital medical data and an AI that can protect itself. That kind of versatility is just incredible, and it really shows you how powerful this one concept is. So what's next?
Well, the next big hurdle is one that you see all the time in technology. How do we make this stuff smaller, faster, and easier for everyone to use?
See, right now, a lot of these diffusion models are, well, they're giants. They're huge, they need a ton of computing power, which makes them expensive and not very energy efficient. So the big push now is all about fine-tuning them. It's about making them more compact, more efficient, so that this amazing tech can run on your phone or inside a small medical device, which would just open up a whole new world of possibilities. So when you really look at the big picture, it's pretty clear that this one idea, mastering noise, is a huge deal. It's helping to solve real problems like the lack of data in medicine. It's building stronger defenses for our AI systems. And as it gets more efficient, it's only going to spread faster. You're really looking at one of the core building blocks for whatever comes next in AI. And that really leaves us with a fascinating final thought, doesn't it? We've seen an AI that can generate things, protect things, and now we're working on making it refine itself to be more efficient. When a technology can start doing all of that, creating, purifying, and improving itself, you really have to wonder, what's it going to be capable of next?